Welcome to the Viewpoint Eye Tracker video tutorial series. This tutorial is a guide for obtaining a good pupil lock. First, you should familiarize yourself with the viewpoint windows to be used to perform the EyeCamera image adjustments. These windows are the EyeCamera window, or windows which combined with the IA and IB tabs in the control panel are used to ensure a good lock on the pupil, and the EyeSpace window and its sub-window Advanced, in which systems other than pupillometry only control how the calibration points are presented to the subject. The Gaze Space window is also of help in checking the accuracy of calibration. To ensure that there is a good pupil lock on the subject, be sure the camera or cameras are positioned so that the eye or eyes are centered in the IA and or IB EyeCamera window, such that the corners of the eye are at the horizontal edges of their respective windows. On digital EyeCamera systems, the eye can be repositioned in the viewpoint window by holding down the right mouse button and dragging the eye to the desired location. Be sure to focus the camera lens or lenses if necessary. The eye or eyes should be well illuminated with the provided IR illuminator. The EyeCamera window displays overlay graphics that graphically provide information about image segmentation and performance. The overlay graphics include thresholding results, which are the green dots indicating dark areas, and can be displayed by selecting the Toggle Show Threshold Dots button. The pupil location and diameter calculation results, which is the yellow oval fit to the pupil, and the corneal reflection location results. The corneal reflection will be discussed in more detail later in this tutorial. Selecting the Pupil Search Area Adjustment button will allow you, by pressing and holding the left mouse, drag out a rectangle to define a limited search area and isolate the pupil from other dark areas that Viewpoint could interpret as a pupil. In the Viewpoint Controls window, mouse click on IA. When the window opens, it will default to where Video has Auto Image turned on and Threshold has Positive Lock Threshold Tracking turned on, as indicated by their respective check marks. The feature method default is pupil location. If the Viewpoint EyeCamera window shows the eye having a good pupil lock, where the yellow ring that is positioned around the pupil is stable and stays locked on the pupil when the subject is instructed to look at the four corners of the display, then no further adjustment is needed. In situations where conditions are not optimal, it may be necessary to manually adjust the brightness and contrast sliders, as well as the threshold slider and possibly the scan density slider. To adjust the brightness and contrast in the controls window, first be sure that the threshold dots are toggled on. Mouse click on the tab for the eye you wish to adjust. If auto image is on indicated by a check mark, mouse click it so that it is deselected. Adjust the brightness and contrast sliders so as to obtain the greatest contrast between the iris and the pupil and obtain a best possible pupil lock when the subject is instructed to look at the four corners of the display. The threshold slider may also need to be adjusted if, after adjusting the brightness and contrast, a good stable pupil lock cannot be maintained. To adjust the threshold, first mouse click on the check mark next to Positive Lock Threshold Tracking to deselect it. Adjust the slider so that the yellow ring is positioned around the outside of the pupil and stays locked when the subject is instructed to look at the four corners of the display. The spatial resolution of the sampling may need to be adjusted to optimize speed and accuracy. The resolution at which the program samples pixels can be adjusted with the scan density slider located in the threshold group. The finest resolution, which is useful when a subject has a small pupil, is with the slider set to the left. For larger pupils, adjust the slider to the right. You may find it useful to use the histogram to help with optimizing the brightness and contrast. You can access the histogram by mouse clicking on the monitor icon in the EyeCamera window and then selecting histogram. The histogram intensity distribution should be as wide as possible, preferably spanning the entire range. The feature method glint pupil vector is more robust against small movements of the head with respect to the camera. If glint pupil vector method is to be used rather than the default pupil location method, here are the steps to be performed after any brightness, contrast, and threshold adjustments have been made. First, from the control windows in viewpoint, mouse click the tab for IA. Under feature method, select glint pupil vector. Select the glint pupil offset adjustment icon on the EyeCamera window. Use the mouse to drag out the offset vector from the center of the pupil to the center of the glint. Press the button to select the glint search size adjustment mode, and then use the mouse in the EyeCamera window to drag out the smallest rectangle that catches the glint at all possible eye positions. Because the glint search size moves relative to the calculated center of the pupil, the absolute placement of the glint search size specification rectangle with the mouse is not important. Only its size is important. After the glint has been isolated, adjust the scan density to use the minimum number of dots that can reliably and consistently locate the glint. Ask the subject to look at each of the four corners of the stimulus window to ensure that the glint and pupil both remain in the respective search boxes and to ensure accurate thresholding for all potential eye movements. For example, the yellow oval outlines the pupil and is fairly circular, and the red oval outlines the glint and is fairly circular. If self-testing, click on the EyeCamera window to bring it to the front, then move the EyeCamera window around to the four corners of the display to view the effects of the pupil and glint segmentation at different positions of gaze. Please note that given a change in viewing direction, the vector variation is smaller than the variation of the pupil or glint alone. The result is a lower resolution and lower signal to noise ratio. There are two other feature methods available: glint location, which is included for educational purposes, and slip compensation, which will be explained in its own separate tutorial.